Okay, this video is about integration by parts. One of the many integration techniques that we can use in finding integrals or doing some integration. Now this technique is particularly useful for integrands involving products of algebraic expressions or algebraic functions and transcendental functions. Okay, for example, if you have something like the integral of x times e to the 2x dx. If you try to integrate this using the usual or what we learned so far regarding substitution method, if you try that, you will realize that you will not be able to find the integral. You will not be able to solve this at all. Another possible example is when you have, let's say, an x squared times cosine of x dx. So this is your algebraic function. Cosine x is your transcendental function. Another example is x to the fourth, and we take ln dx. Try to take the integral of that using substitution method. Well, it will be very challenging and you will possibly be successful. So what is integration by parts? Integration by parts is based on the formula for the derivative of a product. So if we have a function, let's say we have u and v, both of which are functions of x. Functions of x. So if we have, if we take the product of u and v, and let's say we want to find the derivative of that product, so we apply the product rule. So product rule is, applying the product rule, we get the result u times dv over dx plus v times du over dx. Okay, now note that you're probably familiar with the notation u v prime plus v u prime. So it's just a matter of notations, and we know that v prime is, well, that's the same with dv over dx. It means the same thing, and that u prime means du over dx. So the derivative will be with respect to x. This one means the derivative will be with respect to x. Now, one way to make this to make this simple is actually to consider dv and dx as separate variables, and this will come handy later on. All right. Anyway, so going back to integration by parts. So what happens if we try to integrate? What if we integrate this? What if we try to integrate this? So that means we are integrating this with respect to x. So this is our function right here, and we want to integrate it with respect to x. Now, since integration and derivatives or differentiation are inverse operations, so they kind of undo each other. So what you have here is simply u times v, and what we have here is we can take the integral of each term separately. So we have u times dv over dx plus integral of v du over dx times dx. Now you can think of it this way. You can consider this to be some sort of a variable and just cancel out. Anyway, so I have uv equals integral of u dv plus integral of v dx. And we can rewrite this into a form that will actually be the algorithm or the formula for the integration by parts. So we can just solve for integral of u dv. So we have integral of u dv, and that's now equal to uv minus integral of v dx. So this is now the formula, no, sorry, this should be du, this should be du. So the integral of u dv is equal to u times v minus the integral of v du. So just how do you get from this equation to this equation? So that's simply a matter of rewriting your equation, solve for u dv, then uv minus du. Alright, now this technique or this formula only works if u and v are differentiable functions of x. So they have to be differentiable functions of x, otherwise v prime and u prime will not exist. So they have to be differentiable. And also v prime and u prime must also be continuous, so that we can take the integral of this function. So in the next video we will solve some examples that needs the application of integration by parts.